Today's video is going to explore the idea of binary overlays. One of the challenges with these retro systems, particularly if you're running off of floppy disks, is if you want to use some forth code, typically you load source code, which means it's compiling. And although forth compiles relatively quickly, it still grates against our modern sense of how long it takes. So what we're going to do is demonstrate something that I've just recently made. That's an overlay system that leverages the ANS forth word list idea. It always seemed to me that the idea of having a word list, which is a group of forth words, you could think of it almost like a module, but a group of forth functions that have related functionality. You can create a namespace called a word list or a vocabulary, and those words now are isolated from the main body of forth and can speed up your search order because you're not looking for them all the time until you actually say, let's use that word list. Now, I'm going to load in this overlay code here, just paste it into the system. And so it's compiling at about 20 times normal speed here because we're running in an emulator, and when you do a paste, it turns the speed of the TI-99 system up. So typically that would take 20 times longer to compile. But in the meantime, what we have at our disposal is the word list system. So if we look at words, we can see that load overlay is there, save overlay, and the rest of the forth words. The way that we look at this word list search order, in other words, how does forth know what to go looking for, is with the word order. And we can see that forth word list is first, and then a little word list called root, which is sort of like your safety word list, where if everything was deleted, root is always there, and it has just a few words that let you find your way back home in it. Let's take a look at what's there. If we go also, we'll add root to the top of the search order. Let's look. Right. Oh, no, that doesn't work. Oh, I guess I don't have that functionality. We can go back to the way we were with previous, and we can see everything's returned to normal. All right, well, I caught myself here doing a video. But anyway, we'll just assume that root is there. Root has just a couple of words. And we now have this overlay system loaded. And so what I'm going to do is try to create an we have an overlay already created, and it's called, surprisingly, overlay. So let's add the overlay word list to our search order. If I could type, there we go. Now if we look at the search order, we can see that overlay is the first thing, and overlay is also what's called the current vocabulary, meaning all new definitions will be compiled into the overlay word list. Now, if I were to type words right now, I think, I don't want to blow the system up because this is new code. There we go. We've got something that's a little bit shabby. I'll have to clean that up. Nevertheless, let's do include disk1.assembler9900, and this is now compiling the assembler, but it's assembling it or compiling it into the overlay word list. And you can see how much slower regular TI-99 speed is for compiling. This is a few hundred lines of code. Building an entire assembler. There we go, 190 lines, compiled to 2200 bytes. Let's also include the ASM labels, I think it's called. Yeah, these are a way to have labels that you can jump around to on the system. There we go. Now let's save that whole thing on disk 1 as ASM overlay. Save overlay. This is all new. It's saved. There we go. Now if we take a look, this is all compiled into low RAM at hex 2000. Let's take a look at hex 2000, and we can see there's a header and a bunch of names there. The names of the registers are the first things to find, and you can see it says disk 1 ASM overlay. So there's a little header at the top of the memory that the system uses to put things back together again as needed to allow forth to see these words. So remember, our order is overlay first. So if we look at words, we're seeing the overlays words, which are compiled right there. Beautiful. So that seems to be working, although looks like there's some corruption at the bottom where I tried to see the words before I compiled anything into it. So there's a bug that needs fixing. Now, if we do this, previous definitions, this removes the overlay words from the search order, so we can no longer see them. They're still memory resident. If we erase them, I'm going to erase that whole segment. If we look there, 2000, let's just look at a short dump. You can see there's nothing there. And what we should be able to do now, disk1.asm overlay, load overlay, and that pulled that in that quickly, which is pretty neat. TI-99 has some functions for pulling in binary files that are limited to 8K, but it does them very quickly. And now if we look at hex 2000, we can see that our overlay has been brought back in. And we can say, look at the order. Let's do also overlay. And the overlay has been added. And there's our words back again for the assembler. So we can, even with the little bug there at the bottom of the list. So we could now assemble some words. Let's do a word test. Let's go. We'll just make a new add word. Okay, we just assembled that. We go 2 and test. It should add them together. There we go. So there's the overlay system that's been put together for Camel99 Fourth. I'm pretty pleased with it, and the next iteration of this will be to load code into the Super AMS memory card, and then we can pull those blocks of code in from the 1 megabyte SAMS card that I have, and have a much larger system that just allows you to do a lot more. That's it for now.